Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over pH and acid and basic solution, acidic and basic solutions. So let's get into this. So with regard to pH, this video is really going to be kind of the basic fundamental video. I'm not going to get into pH calculations or anything like that. I'll show you the equation, talk a little bit about it, but this video is merely to lay the foundation to pH, to really understand what pH is measuring, and give some real life examples of how pH is related to the things that are around us. I have other videos in which I do go over calculations and how to calculate the pH from the H plus concentration and so on and so forth. So if you're interested in that, please check out one of my videos on the calculations of pH. So let's get into this. So the pH scale, we're probably relatively familiar with it. The pH scale goes from 0 to 14, so I have it written here. So here's pH 0, and it goes to 14. This is 0 to 14 for pure water at certain temperatures, at I think at 25 degrees or 20 degrees Celsius. I can't remember off the top of my head. But this pH scale is based on the autoionization of water under certain conditions like temperature. So if the temperature of the water was to change, then the pH scale is going to change along with it. So the pH scale here is based on specific conditions of pure water. So the pH of 0 is the low end of the pH. This is where it's acidic. So if we're looking at 0 to 14, then the pure water is going to have a pH of 7. Again, if this is under different conditions, different temperatures, pH 7 may not be the neutral, where neutrality is. It might be pH of 7.5 or 6.5 or 6 or 8, right? But for pure water under certain temperatures at room temperature, it's going to be 7. 7 is the is for pure neutrality. And so at pure water would be at 7 at this, for example. So pure water is going to be at 7. If you're lower than 7 on the pH scale, that's going to be acidic solutions. You're going to be acidic. So if you have pH is less than 7, you've got an acidic solution. If you've got a pH greater than 7, you're going to have a basic solution. So any pH greater than 7 is going to be basic. And again, this is for neutral water. This is for pure water under normal conditions like room temperature. Okay, so let's talk about what pH is actually a measure of. pH is a measurement of H plus concentration. So that's your acid. So H plus concentration is related to hydroxide ion concentration. They are kind of inverse of each other. So the higher your H plus concentration is, that means the lower your hydroxide or OH minus concentration is. So they work together in a balance. So for pure water, where you have a pH of 7, they're exactly equal. So the concentration of H plus is going to be equal to the concentration of OH minus. But for pH, pH is measurement of H plus alone. But you should know that if the H plus concentration goes up, then along with that, the OH minus concentration will go down. If the OH minus concentration goes up, then the H plus concentration will go down. But for pH, we're really focused on just the H plus concentration. But there is that relationship between the OH minus and the H plus, or in other words, your hydronium ion and your hydroxide ion. Okay, so what you can see here is on this scale, you've got pH 0, 1, 2 through 14 on the bottom. And then right above that, that's your H plus concentration. So anytime you're given some substance in square brackets, like here I have H plus in square brackets, that means concentration of. So if I have, for example, OH minus in square brackets, that would be the concentration of OH minus. So like I have here. If I have NaCl in square brackets, that would represent the concentration of NaCl salt in solution. So anytime you have something in square brackets in chemistry, that refers to concentration of that substance. Okay. So here we're looking at the concentration of H plus or hydronium ion in solution. And so you can see as we start on this side, we're 10 to the 0. So 10 to the 0, anything to the 0 is 1. And so the pH is going to be 0. Why? Well, here's the formula or equation for pH. Again, I'm not going to do any calculations, but if you're interested in the formula, here it is right here. So the pH is going to be equal to the negative log of whatever the concentration is. If you know anything about logs, basically a log or a logarithm is the power of a given number. So in this case, 10. So power of 10. So log base 10 of the concentration of H plus is going to give us the power of the number, the exponent of the number of the H plus concentration. So that's what pH is going to give us. And again, pH is our measurement of acidity of the substance or basicity of the substance, depending on which side you're on. So this is the equation. Here's the concentration. So if we take the logarithm of 10 to the 0, then we get pH of 0 because the power is 0 there. So it gives us 0. So notice the negative here. It's going to be negative log. So if I take the negative log of 10 to the negative 1, then I get a positive 1. If I take the concentration, this is the concentration of H plus concentration. So this is 10 to the negative 2. If I take the negative log of that, then I get 2. If I take the negative log of 10 to the negative 3, then I get 3, and so on. So you'll notice that the pH is just the negative of whatever the power is. Here the power is negative 1, so it's a positive 1 here. It's a negative 2, so it's a positive 2 there. Negative 3, positive 3. So if you take the negative log of your H plus, it's just the negative of whatever the power of that is. Assuming that it's just 10 to the whatever. So I don't want to get any more complicated than that. It does get a little bit more complicated, but for the purpose of this video, we really don't need to get that complicated. So the main take home here is to notice what's happening to the concentration of H plus. So 10 to the 0 is 1, and then we're getting 10 to the negative 1, which is 1/10, right? 1 over 10. So we're going from 1 to 1/10. And then 10 to the negative 2 is 1 over 100. So that's 1/100th. And then 10 to the negative 3 is 1 over 1,000 or 1/1000th. And then 10 to the negative 4 is 1 over 10,000 and so on. So the concentration of H plus is getting smaller, not larger. It's getting smaller. So the more negative the exponent, the smaller the number. The smaller the concentration. So the concentration is decreasing by a factor of 10. 1 over 10, 1 over 10 to the 2, or 1 over 100, 1 over 1,000, 1 over 10,000, and so on. So we are decreasing by a factor of 10 as we go across. But notice the number of the pH related to the concentration. As the concentration of H plus decreases by 10, by tenfold, right, the pH is increasing by 1. So if I go from 0 to 1, then I'm increasing by tenfold, 1 to 10. or 1/10, or decrease. I said decreasing by tenfold, not increasing by tenfold. So I increase by 1, I decrease by tenfold, by a factor of 10. I increase from 1 to 2, I decrease in my concentration from 1/100th to 1/10th to 1/100th. If I go from 2 to 3, then I decrease from 1/100th to 1/1000th, right? So what's the take home here? If you increase or decrease by 1 in your pH, then you're decreasing or increasing by a factor of 10. So a change in 1 unit of pH is equal to a tenfold change in the concentration of H+. And they're opposites of each other. So increasing in pH means that you're decreasing in the concentration of H+. That's really important to keep in mind. So the measure of pH is a measure of acidity. So if we're going this way, we're increasing the H+ concentration. Increasing H+ is an increase in the acidity of the solution. More H+ ions means more acidic. Okay, so that's really important to understand. More H+ means more acidic. But that's also going to mean a lower pH. So lower pH means that you have a more acidic solution. So let's look at some examples here. So our stomach acid, our gastric juices. Gastric refers to the stomach, right? So our gastric juice, our stomach acid, that is close to a pH of 1. We also know that our stomach acid is pretty darn acidic. It helps us digest our food, breaking down bonds in the food or molecules that we eat. So this is very acidic. So it's got close to a pH of 1. So pH of 1 means relatively high H+ concentration. As we move this way, we're getting less acidic. So lemon juice, very sour taste, right? That sour taste indicates the presence of an acid. So anytime you taste something sour, that's going to indicate some acid. So for example, in your soda drinks, right? When you drink soda or pop, right? Depending on what part of the country you're from. Oops. Sorry. So the pop, I'm from the Midwest, so we say pop. So the pop has acid in it as well. It's got some sulfuric acid in there. That's where it gives it its tangy taste. It's got some carbonic acid. That's from the carbonation in the drink. So when you drink it, you get that tangy, sour taste. That's going to be from the acid. So lemon juice has a pH of just above 2, so pretty acidic. This is one of the reasons why you really shouldn't be drinking a lot of soda, because the acid in the soda can wear away the enamel on your teeth over time. So make sure that you are rinsing out your mouth after you drink a soda, and make sure that you do that so that way you can get that out. Also, a big thing is sugar. Sugar's probably a bigger factor when it comes to your teeth getting cavities and wearing away, because of course bacteria lives on sugar. So if you eat a lot of sugar, you need to make sure that you rinse out your mouth, brush your teeth, but just probably better just to stay away from sodas and sugary stuff. Okay, so that's the end of my public service announcement. Okay, wine. So wine has a pH between 3 and 4, maybe closer to 4. Coffee has a pH of about 5. So coffee drinkers, it's acidic. Coffee is acidic. And then we got milk. Milk is going to be slightly acidic. So slightly acidic on this side here. Oops. Well, I think I have these backwards. Hold on a second. No, I am correct. So milk is going to be slightly acidic. So that's going to be close to pH of 7. Of course, pure water, as I said, that's going to be at 7 at room temperature. And then blood is slightly basic. So it's a little bit above 7s. And then seawater is close to the pH of 8. And then we get here, we have our detergents. These would be like our detergents we use to clean our clothes. Those are going to be close to pH of 11. Again, highly basic stuff. Household ammonia is going to be close to pH of 7. And then bleach is just above 12, so somewhere between 12 and 13. So bleach is very, very basic. So again, if you're looking at detergents and household ammonia, notice that they differ by 1 pH unit. So this is a little bit below 11. This one's a little bit below 12. So they differ by 1 pH unit, which means that the amount of H plus is differ by a factor of 10. So detergents are going to have 10 times more H plus ions compared to your household ammonia. So household ammonia will have 10 times less the H plus concentration than your detergents because they differ by a factor of 1 in the pH scale. So remember, a change in a pH scale of 1 is equal to a 10-fold change in the H plus concentration. Okay, so just to kind of summarize the point is here, so acidic solutions have a pH of less than 7. Okay, so pH less than 7 is going to be acidic. Lower pH equals higher H plus concentration, but lower OH minus concentration. Remember, H plus and OH minus kind of go in opposite directions. So if they are kind of balanced, so here, if you have a lower pH, the lower the pH, the higher the H plus concentration, the lower the OH minus concentration. The higher the pH, then the lower the H plus concentration, and the higher the OH minus concentration. So pH, again, according to the equation, pH is a measure of the H plus concentration. So we're going to be focused on that. But there is that balance between H plus and OH minus. Again, if you have pure water, then the H plus concentration and the OH minus concentration are equal. Okay, so that's it for this video. I hope this was helpful. I hope you learned a lot from this video. If this was a learning experience, if you enjoyed the video, then please, by all means, like the video, share the video, hit that like button. Also, make sure you subscribe to my channel. Hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you have a problem or a question you need help with, then please write that down below. I would love to do that for you, help you with that. Thanks for joining me, and have a great day.